I'm Jeff Johnson. I'm from the Lawrence Berkeley National Laboratory. My background is plasma physics, but these days I've been doing climate science. They're the same equations, different coefficients. My title is Tools for Controlling Change in Your Software. I realized after writing this that that's what we're all talking about. The hard thing about software is writing it in a way that it's easy to change. It's easy to write a program compared to writing a program that other people are going to use and alter. And so I think all of the things that we're going to talk about in this track have to do with easing the process of changing software, which is inevitable. It's inevitable in industry, too. I think we talked before about how scientific software development is different from industrial software development. I think it's different in some ways and not others, because they're faced with the same issues that we are. And they have sort of the same maintenance costs that we have. It's just in relative terms, we're much poorer than they are. And our staffing and our expertise is more rarefied. So it's harder for us to replace people when they leave or to refresh knowledge that goes away. And so I'm going to try and make the case that it's even more important for our community to understand these processes, which are about controlling the cost of changing in software. So I've been asked to talk about version control and continuous integration. Those are related topics, but there's a lot of material here. And we're computational scientists, right? I don't really know what that means, because we're not trained in a consistent way. So I don't know what you know about this already. And so I'm going to ask you, before we start, how many people know what version control is? How many people use version control regularly in their work? OK, how many people don't know what version control is? How many people have not raised their hands yet? OK, so I'm going to go briefly through version control and why I think it's important. But first, let me ask a question. How many people are using version control and they're not really convinced that it's necessary and they just feel like it's extra work? We're all friends here. This is a conversation. You can say this here. We're going to say a lot of stuff here that you won't hear in other parts of the National Science Complex. That's good. If you guys are being honest, that's really good. I think Catherine made a point that there are certain practices that you must be doing, and she mentioned version control as one of them, and I have to underscore her point on this because it's really easy in relative terms to use version control as a matter of practices in your day-to-day work, and B, the value that it gives you is really disproportionately significant compared to what it costs you. And again, there's a lot of stuff in these slides. I'm going to blow through a lot of them. There are some exercises embedded in them. They're designed for you to be able to go back and refer to them. There's a lot of links to external materials on the interwebs and all that. So I'm going to be showing you guys a lot of stuff, but I think that what we hope you will leave this workshop with is the impression that you understand a little bit more what the important ideas are for software engineering, and you at least have some direction for finding out more information. And also, if you've seen all this before, I'm sorry. So here's what I'm going to be talking about. What is version control? There's two kinds of version control. There's centralized and distributed version control. How many people use Subversion for their work? How many people use Git? OK, well, that's telling, because back in the day, when we were having the argument, when we were trying to make the argument that people should be using version control, those groups that were using things like CVS and Subversion. And those are examples of centralized version control. Git is a distributed one. There are important structural differences, and maybe those matter, and maybe they don't, now that we're all sort of headed toward Git. Who uses Mercurial here? Do you use Mercurial and Git? Or OK, so kind of kind of similar things, right? Do you have any comments about the differences between them? Do you prefer one over the other?
So one is offered by the group I'm working with, the other is offered by the university. That's the only reason.
Okay, so he says some are offered by this group and some are offered by this other group, and he works with people in both groups. That seems to be the sentiment, the overarching sentiment about Git and Mercurial. If you are using Git, GitHub is a great development platform. It gives you a lot of stuff for free. How many people know about GitHub already? How many people have GitHub accounts? That's wonderful. So one of the embedded exercises uses GitHub. I introduced the idea of pull request for controlling sets of changes to introduce to a code base. How many people know what a pull request is? Wow, this is different from past years, I'm sure. My job has gotten a whole lot easier, so thank you, everybody. We're going to talk a little bit about tracking progress and prioritizing issues. How many people know what continuous integration is? This might be the newest thing, but there's enough hands up here that it's not a completely foreign concept. Okay. I'm going to argue to you that as a scientist, you should be using version control because what scientists do in following the scientific method is they do their work in a reproducible way. And if you've ever gotten a tarball of source code from somebody and tried to reproduce a result from their code, you know that working in an environment without version control is not the best way to do reproducible work. Version control is well understood technology. It's been around for a long time. It's gotten better and better. And it is essentially your laboratory notebook. And the reason is it actually establishes a common context for discussing a code. What do you mean by the code? Do you mean this tarball in that directory? Do you mean that tarball in that directory? Do you mean the tarball that you've expanded and immediately started editing files for? I can't see any of that, right? If you work on a code and you check it into a repository and you point me at that repository and you say, go to this change number and retrieve that code, now we're using the same thing. So we have an idea of ground truth. And more than that, we even have a chronological sequence of events. If you don't have some sort of ground truth for your source code, there's nothing to discuss. You guys can bat ideas back and forth, and probably you all have been at meetings where people do this. But if you actually want to talk about software, you can't do it without having the same software in front of you. Results from uncontrolled code are not reproducible. Not in general. It's exceptional when they are. Anybody ever tried to share a document that they were collaboratively editing in some way where you kick the document back and forth? Isn't that frustrating? That you get all these divergent branches and everything? I'm not going to harp on this too much. It sounds like most of you have already kind of bought the argument that version control is worth it. So a couple of things. When you both work on a piece of software, you might be frustrated that the version control tool can't actually automatically resolve all merge conflicts with you. But part of what that is the tool shouldn't be able to resolve conflicts in changes because that's what the people are for, right? Software can't understand what you guys want to end up with. So a lot of people don't like certain version control systems or version control systems because they can't magically prevent people from stepping on each other's toes, but that's not actually what it's for. How many people use version control on projects that only they work on? Yeah, so it's a lot easier to reverse mistakes, right? What was I thinking that weekend? Well, that's pretty crazy. You go on a bender And actually, there have been studies that show that if you put more than about 40, 45 hours a week of work into developing software, you start producing garbage. Not everybody buys into this if you look into tech company culture, but it is true that after a certain amount of work, we do become less effective, and this is a way of backing out of that kind of stuff. Has anybody actually brought on a person to a project that you work on solo and introduced them to a repository and made a collaborative project with that? Okay, nodding. Yeah, that's cool when that works, right? You can just start, and the startup cost is actually much cheaper. Okay, so when I say centralized and distributed version control, who doesn't know what that means? You guys are all familiar with centralized repos versus distributed repos. Git and Mercurial are distributed, and every person has a copy of the entire repository and its history versus Subversion CVS, where you have a workspace and the repository lives on a server. But the basic idea is in older version control systems, you don't actually have the whole repo on your computer. This can be problematic when your network goes down, you can't access the server, you lose access to revision history. Distributed version control just clones the entire repository onto your computer. It's a matter of social practice that you have a central repository like GitHub or something, but every copy of that repository actually is the same, and you can actually change the main repository just by agreeing with everybody in your group. Git versus Mercurial, we've talked about these. They're very similar. Linus Torvalds, who wrote Git, who also wrote Linux back a few decades ago, doesn't like Subversion, so he made Git hard to use if you're a Subversion user. That's how he rolls. You know, I don't know if you've ever seen him talk. He's a pretty interesting guy. He hates C++ too, and everything he writes is in C. Mercurial people catered to Subversion users as an attempt to increase adoption, and so there are two communities. By and large, more people use Git nowadays. It's very well thought out. By sacrificing a lot of the deference to past technology like Subversion, they actually made a very clean system. I talked about this a little bit. A version control tool is just a tool. It's not going to magically make code development better, right? You still need to do things like commenting your code. You still need to write good commit messages. You need to communicate with others, including future you. When you come back after 6 months of not paying attention to a piece of code, what the heck is this, right? Or you have a really good weekend, and you come back to work, and you don't know what you were doing. As Catherine said, we're talking about tools and not processes. And processes are very important, but processes are these high-level, malleable things by which people work together. Tools just do stuff. And you use tools within processes to accomplish what the process needs you to do. But a tool like Git doesn't dictate how you should be working day to day. There's lots of different ways of using it. And if you have a project and staff and all that, you should adopt a process that makes it easy for people to do what they want to do. Distributed version control systems, I think the reason that they're more attractive to people nowadays is there's a lot more different processes you can define that use those tools than the centralized version control systems. Even so, for some projects, it's just easier to use centralized version control. You should, and you know, honestly, things like storing binary files are harder to do in Git, and some people use Subversion just to do binary data storage. So there's room for both of these systems. So let's talk about Git. A lot of you guys have used it already. The biggest problem with it is it's kind of hard to learn without putting in time. The command syntax is not the most consistent thing in the world. people who talk about Git tend to come from the computer science background where everybody knows what a DAG is without actually explaining directed acyclic graph, which just confuses people further if they're not a computer scientist, right? But the point about Git that makes everybody excited about the DAG is that it has a very precise control of revision history. And if you put the time into understanding the concepts in Git, you become much more productive. But it's hard to explain to somebody who hasn't done that they can become more productive doing that. And for that reason, teams that have a very successful history of using Git tend to have 1 or 2 Git people on them. And maybe that's a luxury, but what I'm hoping happens is that more people over time, what I think will happen, what has happened in this room, is that enough people are using it that it's just a matter of time where we become more conversant with it. And so the other thing about it is you're not going to define a process that Git can't help you with. It's a very complicated tool, but the flip side of it is it's a very elaborate tool. So Git nouns and verbs. This is what we do with Git. Does everybody understand all these already? I mean, this is a lot of stuff. And stuff near the bottom, like the workspace or the index, are a little bit more esoteric. But cloning repos, commits, branching. How many people have used branches in Git? That's fantastic, because you can't branch in Subversion. In older revision control systems, it's a real problem that they don't actually include this as a mechanism. And so branching used to be a very fancy thing to do. And the fact that you guys are all doing it means that we have made something that should be easy, easy. What do people use branches for? In the back. Sorry?
Developing new features.
Developing new features. And why do you use branches for that?
In case if you're changing, say something like a physics routine that's at the core functionality of the code, and you have someone who is maybe benchmarking, they still need to use, what we usually call the master branch, and because I don't want to mess up their current work with my development work, and then once mine works, I'll merge it into the master branch.
Yeah, so you can have a layer of insulation between your work and their work, right? Because you guys can't work on the same thing at the same time in different aspects without conflicting with each other. So it's a nice way of reducing tension between developers. Any other reasons people use branches? I mean, that's a big one. That's the major one, is making it easier for people to accomplish their work without conflicting with others. Okay, pushing and pulling. You guys have all done this, right? Especially if you're on GitHub, you're hosting your Git repository. This is moving changes between different repositories, right? You pull to yourself, you push to the other one. Okay, so in these slides, I didn't assume that anybody was using a text editor, and so I have a bunch of slides here that I'm not going to go through, but that illustrate kind of the whys and wherefores of Git with some very simple text files, right, that are designed to familiarize you with the initialization of a Git repo, checking the status, basically having a conversation with Git, adding files to it, checking the status to make sure the files are in fact added, committing, changing those files, looking at the differences between what's in the repository and your workspace, and going into the change history, and even backing out changes and creating branches and all this. You guys, a lot of you guys are familiar with this stuff already, but if you're not, or if you're shaky on something, or you just want to see what this conversation with Git looks like, I welcome you to try this stuff, because if you go through these slides and you don't learn anything about Git, then you're already pretty conversant in it. Remotes are kind of a once removed thing. You're using a remote if you're using GitHub, because the remote that you consider your origin, which is what it's named by convention, that is a remote that defines the main repository for your code development. And you probably cut and pasted a command to create a remote called origin if you created a project on GitHub. So it's something that you're already using that you might not be familiar with. But the basic idea is that it's a name of some repository that lives out in cyberspace somewhere that you can push and pull to. And you can work that into a more elaborate process. But the process that you're already using if you're coding on GitHub is a remote with the origin repository. And this is an example of how you can actually manually create remotes and talk with Git about what remotes exist already. So again, I'm not going to go through all these slides because I want to get to some demonstrations of tools that you appear to already be a little bit familiar with, which is just great. This is a gift. This is just such a pleasant surprise for me. Anybody who doesn't know much about Git, it's a good time to be around because there are countless examples out there, and here are some. A lot of them are interactive. They've got fancy JavaScript, interactive Web 3.0 demonstrations of what happens when you type Git commands in a very cartoony and animated kind of way. There are video courses for boot camps and code schools, and of course there's the regular documentation. There's quite a few references that explain some of Git's more complicated features in various ways. I don't know about you, but I like to have something explained 2 or 3 different ways just to make sure that I can paraphrase what's going on. And then there are tools. How many folks use command line Git? How many people use some sort of GUI with Git? Which one do you use?
It's called Source Tree.
Source Tree? That's Atlassian's. That's the company that does Bitbucket, I think.
Yes.
And how do you like it?
Yeah, it's good, but unfortunately not available on English.
Okay. So there's something for everybody. If you're an Emacs person, there's of course a Git plugin for Emacs. If you're a Vim person, there's Fugitive. I haven't tried these. I just use the command line too, because once you put that time in, it's very easy to actually create tools using collections of command line arguments. Has anybody created tools for manipulating Git with command line arguments?
It's not really a tool, it's more of a command line thing, but I have something in my bash RC to tell me when I'm in a Git repository, what branch I'm on.
Okay.
That has been invaluable.
Gotcha. And
there's also, I think, does Git call it aliasing, where you can create a simple short command that means a lot of things?
right.
Commit, but do it verbosely, or all sorts of things.
Yeah, so the tooling is pretty good in Git, right? If you put the time in, it will care for you. Also, there's tons of local options wherever you are. Probably if you're near a university, there's a computer science department that's happy to help you out with that. You don't need to learn it all by yourself. You guys know this. So GitHub, a good number of you already have GitHub accounts. How many people don't have a GitHub account here yet? How many people would be willing to create one today? Okay, I'm not going to ask everybody to participate in an interactive GitHub exercise, but there is an exercise to do with pull requests later on in these slides, and it might be a good first thing to do to create a GitHub account with a particular project that I'm going to show you, and try and modify some files and issue a pull request. How many people have done forking before? How many people know what forking is? Same crowd. Forking is just a fancy way of cloning a repository that changes the name of the repository so that it's yours. So there's a layer of indirection between your repository and the repository you cloned. It's more of a sociological acknowledgement that you're working with the same or a similar code base, but it makes the process of either forking that code base and creating your own project from it, or having your own isolated work environment with which you can add features to the original repo. And so some people use feature branches for adding features to code in their own branch, and other people prefer a more isolated approach where they have a branching structure that they like to manage, and they do that in a fork. It's not really anything new. It's something that GitHub and Bitbucket and these kind of hosting sites have added that really amounts to a fancy version of cloning repos. Also, GitHub and its ilk have issue trackers and wikis and analytics and all this good stuff. And issue tracking is a great way of acknowledging technical debt, which Catherine also introduced. That if you know you did something in a very haphazard way, or you know that you're going to have to go back to something, if you create an issue in an issue tracker and say that, it won't completely get lost. How many people have used any of the tools on this slide before? How many people have used Jira and Confluence? You're working in groups then that use Jira and Confluence. These are project management tools where people get assigned tasks and people create online documentation that either explains in a structured or unstructured way about what they're doing. The reason I bring this up here is that GitHub can actually interact with these things. You can actually commit changes to software and have Jira automatically close out a task for you. So this will play nicely with all your tools. Slack and HipChat are these chat tools that are designed to make people interact in a way that's between a meeting and email. And they're kind of like the age-old IRC rooms. You define channels with topics where you discuss things, and you can actually have GitHub feed a channel with results from a commit. And also, it has the ability to talk with continuous integration systems like Jenkins or Travis CI. I don't know if it integrates with Jenkins, actually. And there's lots of other similar services to GitHub. And they differ in fairly minor ways in the amount of polish that they've been put on them. So why don't we surf to a sample GitHub project? It's not impressive. It basically consists of those two files you would get for yourself if you went through the exercises in the earlier slides. So even if you don't have a GitHub account, this is fully public. You can just click on this link and pull something up for it. You can actually clone this repository using HTTPS without having a GitHub account. And you can do all sorts of nefarious stuff to it. Yeah, so not much there. But you will see that I've acknowledged that there's not much there in the issue tracker, right? This repo needs more stuff. Haven't gotten around to it yet. Those of you who are looking at this page, are you able to create a new issue on this page? Somebody want to try that? Can I get a volunteer? All right, it's on there. Here's a new issue. That's great. So this is a great way to let people know in open source projects that, hey, I found a problem, or I have a feature request or something. Let's see what she wrote. Hi at PESC 2016. And here we can put we can actually tag this with metadata saying that this is a bug or a duplicate or an enhancement. You can define your own categories of tags so that you can search for issues. If you're ever in the unfortunate situation of having hundreds or thousands of issues, you can see how many are bugs versus how many are just nice to haves and all that. But the point is that in the old days, it used to be a big deal to have to stand up an issue tracker to keep track of the bugs in your software. You had to have a server running in the closet or something that was separate from your source repository, and it was awkward to have the repository and the issue tracker talk to each other. This is built right in. And in fact, if you get fancy, you can actually incorporate issue numbers, which GitHub automatically assigns, with your commit messages. And when you push those commits, when you push a commit that fixes a bug, and you say fixes number 13 or whatever it is, it'll automatically, the issue tracker will automatically close that bug. If you guys want to pull up this link, this is a project that actually provides geochemistry capabilities using actually a community code that is written and maintained by Glenn Hammond, who you'll hear from later today. It exposes this capability to other codes via a C library interface that can interact with C++ and Fortran and all that. This is a real project. It's got a GitHub webpage, and it actually has real issues. I think it's got 4 open issues so far, annotated various ways. And it's got, if you click on the little closed thing next to the open there, you can see that we've done some work on this, that your bug tracker will not only tell you what your outstanding issues are, but which ones you've actually closed out. And you can actually learn something about your own productivity on your team from tracking this kind of data. For those of us who have been around long enough to remember how much of a big deal it was to stand up an issue tracker and to actually have one, the fact that this is so easy now makes it a no-brainer. And so actually, you're able to, on a typical scientific software project, bring to bear a lot of tools that used to take 2 or 3 people to maintain and lots of machines. Here, again, these slides are very comprehensive. You can always go back to them if you want to look at them. A fork is just a clone of a repo with its own identity on GitHub, used for certain processes. Here's a little exercise if you wanted to. You can just fork the example repo that you were looking at. And if you do that, you'll be set to do kind of the next embedded exercise, which has to do with pull requests. So again, how many people have used pull requests before? How many people don't know what a pull request is? It's okay, it's not a good name. A pull request is a set of changes. This doesn't exist as far as Git is concerned, or it didn't in the beginning. It's just a set of commits or changes to your software that you want to merge into another branch or another repository that you forked off of or something. This is a process defined at a higher level than a commit that gathers related commits related to a feature or a bug that you're fixing and packages them up and is sent from the person who made the changes, who implemented the feature or fixed the bug, to a person whose job it is to review those changes. The pull request is an articulation that, hey, I have some stuff for you to look at. I would like this to become part of the mainline code. And GitHub and Bitbucket have recognize this is a useful mechanism and have made it easy to conduct a code review using a pull request, that it will create a page for you where you can actually have a back and forth conversation between the requester who generated the changes and a code reviewer who signs off on them before they're merged. So really, it's a request for a code review for a feature or a fix to enter mainline code development. And because of all the notification mechanisms on GitHub, it's very easy to draw people into a code review discussion if you see that, oh, this source file has been changed, this person is going to want to know about that, or there might be performance considerations, let's have this person join the discussion. It's also a great way to trigger certain events. You can actually, via GitHub's integration with other services, you can run a set of tests or do some sort of analysis on the code even before a reviewer gets to it. And save the reviewer time by saying, you know what, this code didn't pass all of its tests, so how about we fix that before we even bother having eyeballs on it. And that's a great way of enhancing productivity and making it easier for people to understand how it is that they're affecting the code. If you issue a pull request full of changes that keeps all the tests working, there is hope that it will survive a code review process. If you break everything, you don't have much of a place for arguing that it's ready for code review yet. And this will get us into the idea of continuous integration. And again, the reviewer, it's always nice to have a human being as part of the process, just to make sure that style issues or performance considerations that might not be captured by tests at an early stage of a project are addressed. And when everybody's satisfied, the developer or the reviewer, however you want to set it up in your process, somebody whose responsibility it is, can perform a merge, which closes the pull request. And ideally, if you mention an issue or a feature request by number in GitHub, in the conversation or the description of the pull request, the issue tracker will automatically close it out. It's kind of amazing how much of this used to be manual labor that is highly error prone that has been automated by these platforms. Does anybody have any questions or comments so far? I'm just kind of going through this stuff, and I hope that you guys don't know all of it, but if you did know all of it, I'd be pretty happy, actually. So here's another exercise. You can go ahead and once you've mangled the example repo that you forked, or if you went through the forking exercise and went through and edited some files, and you wanted to issue a pull request to me to have your changes reflected in my version of the example, you can follow this process to issue a pull request. If you've never done a pull request before, it's a good exercise. And I'll even chat with you on the pull request page if you want to. Continuous integration is one of these ideas that once you're set up with version control and you've decided how you want to change your software using these ideas, these pull requests, these code reviews, and you're tracking your issues, the next thing you can do is you can make it easier for automated tests to be run when you issue a pull request. In other words, in more general terms, what we would like is we would like for code changes to trigger automated builds or tests on target platforms. One of the challenges in HPC is we have pretty weird platforms, right? They can range from your MacBook or your Surface Pro or whatever to Edison or Titan or Mira. And all of these platforms are different. If you're using any libraries on these platforms that are built in a way that isn't how they come with the machine, or if you're using a lot of libraries, you get into third-party library management, and there's countless issues that are completely mundane, that have nothing to do with your code, but that have to do with the code that your code depends on, that create kind of astonishing results in which your code can fail on this platform, but not this platform. And so what you would like is actually a set of target platforms to run tests whenever you make a change to the code. How many people have exposure to a testing system that works on all of their platforms of interest? And what does that look like? What are you using?
Actually, this was part of a project we started at my research group work at University of Maryland. It's called DICE, and it works on having some test scripts that works on Mac, Linux, and Windows with Sigwin. So it's a bunch of scripts written with C and Python, and mostly make sure everything is cross-platform before we release it.
So that's great. And so have you noticed that it's made people more confident about changing the code?
I guess so, yeah. It's also like it's also written in a way that's not specific to any specific language. So it's more of like you can plug in whatever test tools you want to add, and just like it will build on top of it.
That's great. That's great. And woman in the back, what do you guys have set up?
So it's not my personal research, but I sometimes contribute to an open source project called Python for Nuclear Engineering, Pine, and they use Travis CI to test builds on a few different Linux platforms and also Mac. Every time that rebuild is triggered every time a pull request.
Right. And actually, I'm going to talk about Travis CI. And I actually have this Alchemia project I pointed you guys at uses Travis CI. And if you don't use it, there's a configuration file in that repo that will give you an idea about how to configure it. It's just one configuration file. It's pretty easy to set up, but there is some doing to figure it out because the documentation, last time I checked, was not that great. So this is stuff that you can use if you do your code development on GitHub, and it's likely that Bitbucket has its own ecosystem of tools. I don't know if they're using Travis CI, but if you're using these tools, it's not that hard to stand up this kind of automated test system. It's immensely helpful. One thing that it does away with is the superstitious notion that we can't change the software because it works. Oh God, don't change it. We don't know what'll happen if you change it, right? We're getting the good numbers now. We have to leave it alone. That's true if you don't have good testing in place. But the reason I think Catherine called out testing as possibly tied for first place, possibly close second to version control, is that tests are what give you confidence that you didn't break everything. And I don't know about you, but I break things before I make them better in general. I don't seek to do that, but it seems to happen. It's a lot of work to get here. A typical scientific project that started before the last few years when all of this was available is going to have some issues getting to a form where this makes sense. You need a reasonably automated build system. Alchemia, the project I pointed you at, uses CMake. These are both configuration systems that have build systems attached to them. And they're both not a trivial amount of work. I mean, they're different amounts of work, and they appeal to different sensibilities. But you have to have an automated build system in place. You also have to have an automated test system that has some degree of coverage that gives you a warm, fuzzy feeling when tests are passing. If you have one unit test that tests that function that you wrote only to see if you could write a unit test, that's not what I'm talking about. You're going to have to test the things that you actually use. You can even just do some smoke tests of running a simulation, if you're a simulation scientist, just with an input to make sure that the thing gets to the end. And maybe you can do better and compare your answers to a data file that has the old answer in them. If you're really knocking it out of the park, you have some sort of analytic solution to your problem that you're studying if you have the luxury of being in a field where analytic solutions exist. I know in fluid mechanics, we have a few of those. In subsurface science, it gets a little harder. In climate science, this just isn't done. In climate science, people look past their thumb and they go, yeah, I don't believe that. And you say, why don't you believe that? Well, and then you devolve into a very esoteric discussion. And getting two climate scientists in the room to agree on that is not as trivial an exercise as you might think it is. Anyway, you need some idea of what constitutes success. You also need a set of systems on which the tests will be run. You have to be doing a lot of things right before you even get here. Cloud-based continuous integration is great because you don't need the servers running in your closet, right? They're already being successfully used. We've already had Travis CI mentioned, so why don't we just talk about that? Travis CI is a service that integrates kind of seamlessly with GitHub. It's free for open source projects. They'll give you a certain amount of concurrent builds and tests, and it's fine. I use it for a couple of open source projects, including Alchemia here. It supports a few environments, not as many as I would like, but hey, it's free, right? You can get C, C++, Fortran. You can get the GNU compilers, Clang. There's talk of getting Intel compilers for those of you using Fortran with features past Fortran 2003. That could be very important. They have Linux and Mac platforms. Their Macs are pretty old. They only have about 2 cores on them. I've discovered this empirically. So you have to be careful to take subsets of your tests, particularly if you're doing I/O tests that don't use more than 2 processors. There are limitations, but it's free, and it's not impossible to configure. Like I said, there's one relatively simple, reasonably flexible configuration file, but this is a system that has evolved, and documentation is not great. So I would say, if you're interested in this repository, there is a file in the top-level source directory called .travis.yml. YML files are YAML. It's yet another markup language. Very simple. And actually, if you wanted to, you could go into this repository and edit a file there that breaks it and issue a pull request, and you would see, and I dare you, you'll see Travis automatically running its automated tests and coming up with a red X, which is what it uses for no, this is not yet soup. If you've done your homework and you didn't break it, you'll get a green check mark. So we're just reinforcing the same social norms. So at this point, I just want to wrap up, and then we can discuss whatever you guys would like to discuss. You need version control. You guys know this. That's awesome. Distributed version control systems are more popular because they're more flexible. They don't tell you how to do your job. Great. Git seems to have won the war in distributed version control. You're not going to need anything more powerful than Git. I wish it were easier to use, but actually once you've been indoctrinated, it's not that bad. There's lots of documentation, there's lots of support, there's lots of institutional knowledge about it. You don't have to do it yourself. And if you bother to learn it, the payoff is real. And if you don't have a Git person or a Git sensible person on your project, you may want to become that person. You'll be very valuable. You can train other people. Or you might want to cuddle up to a project that has a Git person and pick their brain. Also, we talked about GitHub and similar sites like Bitbucket. They are very capable, cost-effective development platforms. They have admitted that software development is a social process, and they have eased the process of communicating in the context of source code. You can actually conduct code reviews in which you annotate source code on GitHub pages and say, what are you doing here? Can you add a comment here? I am concerned that you're using the wrong sorting algorithm for this kind of data, and so on and so forth. There's a lot of useful services that can be incorporated on these platforms that will just take work that used to be rote to improve the quality of your software and automate it. And continuous integration is an example of one of these that has been made very practical by Travis CI and even other continuous integration services out there. Travis CI was just the one that I found when I was looking for something. There's probably other ones. Most of the other ones that I was looking at the time had to do with productivity languages, which Catherine mentioned haven't come far enough in high performance computing. But there's at least 2 other ones out there that do C, C++, and Fortran. So you have options.
So I have a question I think that's kind of fundamental to beginner Git users. I see a lot of Git users using Git as a form of backup in lieu of a form of good version control. I'm curious what you would recommend in terms of practice and how good version control looks in terms of a commit and a commit history and a content of a commit, because a lot of people will use it and they'll just dump a Git commit at the end of the day with a bunch of junk in it, and that's really not that useful, I don't think.
This is a great question. Git is designed to help you track your changes. All of the things that we're going to be discussing today are tools that help you change your software in a controlled way. And what this means is that when you do some work and you commit it, you might be doing that under different circumstances, right? Sometimes you need to change computers, right? And you want to keep the work that you're doing and you want to see it over there. That's not the greatest commit in the world. You have to do it sometimes. But I think the people you're mentioning just, they do a bunch of work for the day, and then at the end of the day, they commit, and their commit message is, worked a lot on this part, on this feature, or I did some work on the code. Well, okay, you can do that. But all of these tools that offer visibility at the commit level are not going to help you do your job. If you introduce a bug in a commit that has 90 files in it that have changed and says, worked on the code, you've not given yourself any help. It might be better to confine commits to isolated sets of changes on this or that feature or in this or that file. Does that answer your question?
Yeah, I mean, that's exactly what I was getting at.
Yeah.
Logical commits, logical changes, I think, are very valuable. And if you get used to doing it that way, I think it's a very useful thing to have in your...
Absolutely. And there's several things that we don't have time to discuss that will help you if you adopt that philosophy. So that's just a good idea.
On a related question, could you speak a little bit about suggested workflows for Git?
There are several workflows out there. There's what is called Git flow, which is a little bit elaborate, but if you're on an elaborate project, you might need it. There are several ways that you can adopt changes into your master development branch from other branches. You can use Git flow, which dictates a branching structure for doing feature development and even releasing. And it's elaborate, and you're going to need some buy-in from some people, and some people who have less stamina for Git are going to be grumpy about it. But it does work, and it has been shown to be productive. On the other end of the spectrum, some people say, forget it. I'm not going to tell you how to do your branching. Fork it, do what you want, and issue pull requests from your fork, and we'll review it at that level. There are several of these things, and I will go back and put those slides in because it's in there. There's ongoing debate, but I think the lesson for us is if your team likes one better than the other, and you're not seeing people abuse any part of that workflow, that's fine.
So talking about continuous integration, and also when you mentioned that we don't have a ground truth solution for the unit test we run, and something I run a lot in it, like if you're working on an agile project, the interface keep changing every few months, and eventually also if you don't know the ground truth, whatever you put as your ground truth, like we said, like, oh, if it's less than 10, that's correct, and then later on, okay, so it's the number changes a little bit because of the implementation changes. So like 10 now it's not working. That's fine. Maybe you can say if it's less than 9.8 is correct, and then you have to go and like now the test you wrote becomes like an extra overhead for you. Just like you don't just change the code, you have to go and keep changing the unit tests you wrote. So what if you face that? How do you deal with this problem to be more productive in this agile development environment?
So what you're saying is a corollary of the fact that when you write code, it needs to be maintained, right? When you write tests, you're writing a form of code. The problem that you're describing is more to do with the science and the nature of the problems you're studying than it is of the tools. Git and GitHub and all these are tools that will help you. If you want to be able to assert that you know what you're doing, you have to have a test that says, I believe this or I don't. Because if you don't have a test, you certainly don't have to maintain a test. But you run the code, you generate a plot, okay, send the plot to the journal, but is it right? I mean, is it even worth sending to a journal if you can't say whether you agree with it or not? It's a very difficult problem, but it's not a problem that the tools can solve. I would say one way to mitigate the cost of testing is to adopt a testing framework that makes it easy to write tests without a whole lot of boilerplate, so that you can go back and change those things that need changing without worrying about, people, because we're detail-oriented, people sometimes make elaborate structures like test suites of other test suites and all of this very dependent structure, and you realize, oh, we don't need this anymore, so this whole set of suites has to be restructured. Try and be humble about your understanding of the system, and don't get elaborate about any immature system, because the structure is probably going to change. The reason that we have a set of talks on controlling change in software is we don't get it right the first time. We don't know what we're doing. That's why it's called research. And even in industry, they don't always know what they're doing, right? Nobody does. If you're writing banking software for the 1,000th time, okay, great, go do that. But the rest of us who haven't quite figured out how to express this richly have to be humble and not articulate that we think that there is this elaborate structure, because if you just have to go tear it down at the end of the day, you've done yourself a disservice. And the worst thing about that is every time we get it wrong in software engineering, the team blames the software engineering, right? Instead of counting all the costs that you have without engineering process. This is the Heisenberg uncertainty principle.